Welcome to this video. We're going to be talking about permutations and combinations. This is aligned with Mathematics Analysis and Approaches, Higher Level Standard 1.10. So suppose you are picking teams for a soccer game, and there are 3 players left to be chosen: Alex, Brian, and Callie. How many different ways are there to select these 3 players? So this is a question we're wondering about. To begin, you have 3 choices: Alex, Brian, or Callie. Once you select one of those people, then you'll only have 2 choices left. And after that, you'll only have 1 choice. In other words, you'll have 3 times 2 times 1, or 3 factorial, which is equal to 6 choices. Now that is an example of what we call a permutation. Now suppose instead there were actually 5 players left to choose from: Alex, Brian, Callie, Devin, and Eugene. How many different teams of 3 could you make? And keep in mind that a team like Alex, Brian, Callie, and Brian, Alex, Callie, and Callie, Alex, Brian, the same people makes the same team. Doesn't matter the order which you choose them. So that's key. Alright, so here's how we figure it out. At first we have 5 choices. Then after we've selected one person, we're going to have 4 choices. And after that, we're going to have 3 choices. So 5 times 4 times 3 is 60 possibilities. Now we can actually write this out in a different way. 5 times 4 times 3, which is really equal to 5 factorial divided by 2 factorial. Now write it like that because you can rewrite that as 5 factorial divided by 5 minus 3, where 5 is all the options and 3 is how many you're actually choosing. And so that's equal to 60. But remember, some of those teams are actually the same people picked in a different order. So to be precise, each team of 3 could have been picked in 3 factorial, or 6 different ways. We just figured that out on the previous slide. So we divide 60 by 6, and that's also equivalent to 5 factorial divided by 3 factorial times 5 minus 3 factorial, and that gives us 10 unique teams. So I wrote it out like this because we're going to deal with the formula in a little bit, but this is an example of a combination. So the question of permutation versus combination can often be difficult to navigate. So you're asking questions like, which formula do I use? What do I need to look out for? So here are the 2 situations you're going to mostly encounter. The first one is when order matters. So that is a permutation when order matters. And your formula is given by n factorial divided by n minus r factorial, which is like the first slide. Where in the case, n is how many options you have, and r is how many things you're choosing. So we write that in this following notation: n pr, n choose r, where n is the number of items and r is how many you're choosing. When order doesn't matter, that's known as a combination, and our formula for that is n factorial divided by r factorial times n minus r factorial, and we write that n choose r with the c. So keep in mind that sometimes a particular problem has no clear solution, so you're going to have to think critically about it. Questions you can ask yourself when solving these problems: number 1, does order matter? That'll tell you whether it's a permutation or a combination. How many options are there, and how many things are being chosen? That will tell you what is n and what is r. Can you draw the situation to help better visualize it? And lastly, once you've finished, did you think about every scenario? In this lesson, you're also going to need to know how to simplify expressions that involve factorials. So the trick to doing this is to remember that factorial is just really that number times every number less than it. So if you're given an expression like n factorial, that's just n times n minus 1 factorial. Or similarly, n plus 1 factorial is just n plus 1 times n factorial. So you just move it over 1 and expand it just a little bit, so that way you can get some things to cancel. Alright, let's try some practice. So let's simplify this. N times n plus 1 factorial is just n plus 1 times n factorial divided by n factorial. N factorial and n factorial will cancel, and I'll be left with n times n plus 1. And that's my simplified answer. Let's try another one. N factorial here is the same thing as n times n minus 1 factorial. And I did that because I noticed here is also an n minus 1 factorial. So minus n minus 1 factorial divided by n plus 1 factorial. Okay, so n minus 1 and n minus 1 I can undistribute and get n minus 1 factorial times n minus 1, because I'm left with a 1 right here and an n right here. Okay, and then this is all divided by n plus 1 factorial. Now this bottom part, I'm going to undo 2 times to get it all the way to n minus 1 factorial. So that gives me on the top n minus 1 times n factorial, n minus 1 factorial times n minus 1 divided by n plus 1 times n minus 1 factorial. Now these will cancel, and I'll be left with just n minus 1 over n times n plus 1. And I've eliminated factorial, so I'm done. Alright, let's try a permutation combination example. So the question is, in how many ways can the letters in the word candle be arranged? So first question, does order matter? In this case, yes, because we're talking about a word, and the order of the letters will change the word, so order here does matter. Number 2, how many options are there and how many things are being chosen? Well, we've got 6 letters, and we're just rearranging them, so we've got 6 spots. So n is going to equal 6, and we're choosing r. R equals 6 as well. So R and N are both 6 here. Can I draw the situation and better visualize it? I don't really need to because it's just a word. Did I think about every scenario? I'm going to cover that when I get to the end. So here we're going to have 6, choose 6 in terms of a permutation. You can put this expression into your calculator and it will calculate the answer for you. And so when you do that, you get 720 ways of arranging the letters in the word candle. Did we think about every scenario? We're good to go. 720 ways is our answer. Okay, let's try another one. In how many ways can a group of 4 boys and 3 girls be arranged if no girl is to sit next to each other? Okay, this one's going to be a little tricky, so pay close attention and think critically about it. First question, does order matter? Well, we're arranging the boys and the girls, and so we're assuming they're different people, and so the order of them will matter in this case. So we're going to deal with a permutation. In a second, I'm going to show you why it actually also includes a combination. So I'm going to write P and C here. Next question, how many options are there and how many things are being chosen? To answer that, I'm actually going to draw this situation. So we're assuming we have a group of 4 boys, so I'm going to let them be represented by circles. And then we've got 3 girls. Now, in order for the girls not to sit next to each other, they have to go in the spaces. But keep in mind, they could also go on the outside. So the girls have 5 possible places they could go. So you want to say of 3 girls and there's 5 places they could go, that's actually 5 choose 3. And I did C for combination because you're just shuffling the girls around, and in that case, when the girls, let's say 3 girls were here, here, and here, and then they were flipped around in a different order, it would still be the same location. So that's why I did combination, not permutation. But here's where it gets tricky. I'm also going to include permutations because I'm asking arranging the boys and girls in different order. So I've got 4 boys. Let me just write B here. And I want to ask the question, how many ways are there to arrange those different 4 boys? Well, that's similar to the very first example we did. So that would be 4 factorial. I'm arranging 4 things and I'm not picking 3 out of those 4, but just 4 things, and I'm arranging those things in the positions they are. So that's 4 factorial. And then similarly for the girls, I can arrange the girls in 3 factorial different ways. Now I'm actually going to multiply all 3 of these things together. 3 factorial times 4 factorial times 5 choose 3 factorial. And that's going to give me 1,440 ways. So you really had to think critically about that one. Okay, let's try another one that's a little bit easier. How many 4-digit numbers can be made using each of the following digits only once? Okay, so in this first example, we've got 5 digits to choose from. So here my n equals 5. And we're choosing 4 of them because we're making a 4-digit number. So because order matters because we're constructing a number, I'm going to use permutation. So it's 5 choose 4 in terms of permutation, and that's going to equal 120 different numbers. Okay, and the next one, you're going to have to think about it a little bit because a number cannot actually start with 0, which means for our first choice of the digit, we only have 3 choices. So I'm going to do 3 times, and now from there, I'm going to have, because I've already chosen 1, 3 choices left, and only 3 spots left to fill. So from there, it's going to be n equals 3, r equals 3. So that will be 3, choose 3. That one was a little different from the first one because 0 cannot be the start of a digit, but it can be somewhere else in the number. So this gives us 18 different ways. Okay, last question. There are 8 boys and 5 girls who attend the Senior Mathematics Club. Find out how many ways a teacher can choose a team of 6 students to represent the school in a competition if, part A, there are no gender restrictions. Okay, so we got 8 boys plus 5 girls makes 13 students in total. Now we're only choosing a team of 6. So remember back to the soccer example, when we're choosing a team, order doesn't matter because if we pick the students in different order, they're still the same team. So we're going to do 13 choose 6, and that's going to equal 1,716 different teams. Okay, part B. The restriction is the team has to be made up of 3 girls and 3 boys. Okay, so that composes the whole team of 6. So of the 5 girls, we need to choose 3 of them. And then we're going to multiply that by of the 8 boys, we need to choose 3 of them as well. So 5 choose 3 times 8 choose 3, that gives us 560 different teams. And all right, that's it. So go ahead now and try some practice on your own.